Hmm. Oh no, it's gone back to being black on Twitch. Oh no, it's working. Good. Yeah, I'm super paranoid about that now. Cool. All right, today we're going to implement Phong lighting. I'm pretty sure that's how you say it, again. Just basically porting it from the SDL3 version to Vulkan, and then maybe doing some terrain generation after that. But I thought actually I should have a look at the implementation again. So this is the directional light, this is the point light. So we've got the attenuation. Which makes sure that your light has a particular radius. Well, it's not exactly like a radius because technically light travels infinitely, right? So it's going to hit this object and then come into the camera. That's kind of the idea. But as it gets further away, it becomes more attenuated, which I don't really understand. Intensity decreases over time. I assume that's got to be because why? Doesn't matter right now. Let's have a look what we got at the moment. So last night, just before I went to bed, I had a little bit of time. So I did a little bit of work. So I added a little sort of noise to the world. It looks a bit weird on this model, but you can see these little pixels. And I also added the debug shapes back in. So we got a second. It's not exactly a render pass because of the dynamic rendering in Vulkan, so you can actually do a pretty cool thing, which is, I'll go down to where that is actually, CMD draw. So this is the draw command for the sponsor. Debug drawing is here. So we've got a new pipeline, which is called the debug graphics pipeline. And we just set up some things for it and then draw 14 of the debug shape max, which is just a constant. I think I set it to 100, 128 maybe. Yeah. So that's just our uniform. So if you remember, well, if you saw the stream previously, but if you didn't, there's basically a debug shader here, and it's got a uniform here, which I've set to 10, but actually should be, I guess, 128 positions. And these positions will determine where these shapes are going to be rendered. And then the fourth component, because they're vec4, are actually a bit field, which lets us know what shape we should draw, so quad, triangle, or cube, and then what color. So I've got green, red, blue, yellow, magenta, orange, magenta, cyan, and lime. So they're just packed into the first 4 bits for the type, and then the next 4 bits for the color. And then we've still got, what is that? 24 bits remaining that we could put other stuff in, but I just haven't thought about what to do with that yet. So yeah, pretty cool, I think. So you can see this is how we draw a quad, this is how we draw a triangle, and drawing a cube is actually, we're going to index this array here. Not this array, cube vertices, which I suppose I should make capital. It's not really constant, but I could make it constant. Hello, I'm trying to make this capitals. No, it's not going to work today. Okay, that's fine. I was probably pressing the wrong button somehow. Cool. So now we've got cube vertices is a constant. That's all good. And the fragment shader for debug is really simple. It's just what's the color. I mean, I don't need to make this variable. I don't know why I did. Maybe I was going to do something else. And then we just output the color. So this could just be in frag color, and then that's it. That would be fine as well. Okay, something weird is going on here. Yeah, all good, I think. Right, so also you can turn on and off depth testing for the debug layer this time. So in the SDL version, I didn't have that option. I guess because that's the way the pipelines were. Maybe you could change it dynamically, but I didn't really get up to that point. So that's kind of cool if you don't want to see them through walls. I haven't got a button to turn off the debug shapes yet, but I'm going to add that. But yeah, let's get into the lighting. So we actually had a simple 3D shader, which is right here, which has lighting stuff in it. So I'm just going to split the screen, and we can get the lighting stuff up on the left here. So we had a point light type, a uniform buffer that has the player position and the light position. So we need the player position to calculate the lights basically, because if we're drawing a pixel, we need to know where we're looking from to draw the reflection. Actually, do we use that? No, that was just for that was for, I think it's called specular highlights. Where is it? It was in basic lighting? Yeah, so specular, where is it? I think it's here, specular lighting, yeah. So this used the player position, and it draws this little reflective bit. So you know when you're looking at something kind of shiny, it's because the light is shining right in your eyes. It could be very bright, but it might not be shining, you know, reflecting straight at you. But in this case, that's what this is sort of simulating. I was looking at also PBR, which is physically based rendering, and it's got this cool idea of microfacet model. So the rays of light go into this material, and they sort of bounce in different directions based on the roughness of the surface. So a more rough surface would look, I guess, more matte, less glossy, less shiny, which is kind of cool. I don't know if I'm gonna do PBR. Maybe. I'll think about it. Just because the game that I'm gonna make, I don't really think I need this kind of material, these kind of materials. It's gonna be more like, actually, let me see if I can find an example real quick. Just a second. Here we go. I don't have a link to this. Can I open in the browser? No. Well, that's a bit annoying. It's in a DM, so I don't just want to put the DM on the screen, that's all. Well, hang on a second, I'll see if I can find it on Twitter. Yeah, here we go. I just gotta make sure I'm not leaking anything. So basically there's this guy on Twitter, his name's Zakara, making a game called Voidborn. or made a game called Voidborn, but also working on another game, I think, or is this Voidborn? I'm not sure, but this is the kind of style that I'm really interested in. I really like this. It's sort of lo-fi, but obviously modern at the same time. And there's another one here. Can I open this? Let's see. Yeah, I think you can look at my Twitter. There's nothing weird on there. So this is really cool. Yeah, I just really like the vibe. I like this, and I like the style. So it's not really like super high fidelity, but it's very nice. It's got really good composition. I don't know how it would work for sort of a sandbox kind of game, which is what I'm making. So we'll see. But yeah. So anyway, that's why I'm probably not going to do PBR, because PBR, as far as I can tell, is all like super realistic, shiny graphics, which I don't really need. All right, so cool. Let's get into the lighting, eh? Hey, the Dot Wolf says, really neat. Looks like old school Devil May Cry scenes. Yeah, it does actually. Yeah, it's really nice. So, we need a uniform buffer object for the specular, but we don't need that right now. The light position is, I think it's hard coded right now. Yeah, so I'll just leave that. We'll grab the point light struct. That's a type that we're going to need to use. Calculate point light. I guess that's not going to change, so that's fine. And then we just had a hard-coded point light in here last time that was moving based on, it was moving based on this. So this time, if we go down here, where is it? So we got the terrain color. So the terrain color is just this noise thing. Which just puts pixels there. Well, they're not really pixels. It just sort of rounds it to this value here, which is 1/16 of a meter. And then adds a noise value. So yeah, we've got the light color, which is this. So we're going to do sunlight plus light color, I believe. Okay, that should be good. And this position we're going to change because it's not moving right now. So I'm just going to, actually I'll comment it out. Light dot position is going to be, let's just do 1, 1, 1. Okay, looks like, did we compile? Yeah. Okay, oh look, the light's kind of working. Oh, there's no attenuation yet? Is there? Let me see the code. There is. Okay. So, what is this distance? Where does that come from? Light position minus frag position. Okay, that's fine. This looks way brighter than in the STL version. That's why I'm a bit confused. Alright, looks like I was disconnected. Let's just wait a second. Just make sure the stream's still up. Okay, I think it's still up. Yeah. I need to stop eating those biscuits. I'm starting to get a double chin. Not good. Alright. Great. So the light looks, to me it looks kind of bright. Which is weird. I'm just going to look at it again. Could it be because the sunlight color is gray, so everything is tinged blue? If the sunlight color was yellowish, would that change this? So yellow would be something like this, I guess. Sorry, the sunlight color was white. Nope. I mean, it does look a little bit nicer, I think. But yeah, okay. It's just going very far, the light. If I look at those... Oh, where did the browser go? Did I close it? No, I put it on the other screen for some reason. Oh yeah, I was showing the stuff. If we look at the other attenuation values they had down here. I think was it this one? No, it was light casters. So there's some values here from Ogre 3D. I think we're using this one. No, we're using 32, right? 1.0, 0.14, 0.07. Is that right? No, we're using 0.09, 0.032. That's this one. We're using this one, 50. So let's see. Setting the value depends on many factors, the environment, the distance you want a light to cover. Okay, so if I was going to put, if I put this value in here, 0.7, 1.8, the linear and quadratic, what's going to happen? Okay, I see. So that gives us a, I mean, it's not exactly a smaller light, but you get what I mean, right? We get a smaller area being affected by the light from our point of view. Okay, that's cool. That's cool. Okay. That means when we create a light, we can probably pass in some kind of value like size, I guess. And then size would just change these values. Constant, linear, and quadratic. So constant's always 1. I don't see... I mean, I guess I could change it, but if constant is always 1, we can remove this variable. Right? It doesn't need to be here. So we can say, maybe make a table. So I'll grab this data here. It's going to be in a weird format, but let's just see if this works. And I'll put a little table up here. Okay, so what we want to do is delete until there. So we always have the constant, that's fine. Nope, that's not what I wanted. Okay, there's like, okay, I can't actually paste this because there's weird Unicode characters that are not visible. So I'm gonna have to maybe, can I paste without, you know, in some programs you can paste text only or something without the Unicode. Doesn't look like it. Okay, I'm just gonna have to copy them. That's annoying. So, what I'm thinking is we make a point light. What should I call it? Setting size. I don't know. Point light sizes maybe, and they can be vec2. Wait, this is all wrong. Vec2 array. That's how you do it in OpenGL, right? It's like C. It would be like this. Yeah. Yep, I think that's right. Okay, and now this is going to be... No, this is probably going to be after the name. I'm getting confused. So, we have something like 0.7 and 1.8, which is what we just used. And then 0.35, 0.44. Wait. Yeah, okay. 0.22, 0.2. So let's just say we've got these three for now. And then I guess if I was going to choose a size, how would I do that? Just trying to think about what the calling code should be like. So if you want to make a light, pass in a point light struct with... See, I wouldn't put this in here. Linear quadratic, we don't need that. Diffuse and ambient, I guess they could be options. But maybe we'd just have a uint. And this would be size. But then we don't know how many sizes are available. So in this case, it's 0 to 2 inclusive, right? But that's fine. We could use an enum. It's okay for now. So we've got a point light, and we just get rid of this, and then we say light.size equals 0. And then when we calculate the point light here, it had linear and quadratic, but instead of that we would put point light size dot x and dot... Actually, these could be structs. Might be a little bit clearer. Struct point light attenuation. Is that how you declare structs? Yes. And then we would have a float, linear, float, quadratic. Then in here we could have something like this. So this shouldn't be size, I guess it should be attenuation. Z. Yeah, I don't like it either, but that's fine. Yeah, okay, that's fine. So this would be linear, and then this would be point light attenuations, light.size, quadratic. So I think that would work. It's not the nicest. So we should get the same result, assuming it compiles. Yep, it did. And yes, we do. That's good. So if I change this to size 2, we should get a much larger light. Yeah, I think that's much larger, right? It's hitting the other side now. Yeah. That's good. means we can use less data. Less data makes everything faster. Okay, so I'm probably going to add more options here later. I'll just put it to do here. Okay, and now on the Odin side, I don't really know where to put this, but oh man, there's so much code in here now. Let's say I was gonna put in a point light struct. I'd want to have a position, thank you, and diffuse, I guess, and ambient, and then a size, which I will use uint as well. That's actually u32. Okay, that's all well and good, I think. So this would match this, these structs match, which means I could pass these in as a uniform, right? Straight to the fragment shader, along with player position and light position. Well, not with light position, because that would be multiple point lights. Now, we don't have this restriction of using STD 140, which, what does that even stand for? I want to figure out how to say it properly. Is it just standard? Is it standard 140? Like, what does the STD mean? I don't know. But we don't have the restriction of only using this. Although actually vec3s remain unchanged from 140 in 430. Okay. And 430 can only be used with shader storage blocks, not uniform blocks. Okay, so we probably want to use 140 anyway. I know this is OpenGL though. Clarifying Vulkan GLSL STD140. Right. Vulkan has 3 alignment requirements that interface objects can be laid out in. Extended alignment, also known as 140. Base alignment, also known as 430. Scalar alignment. Right. Okay. So if we don't allow standard layout, then if we don't request this extension, then we only have 140, I guess. Is that right? One example is needed when the application doesn't want the array stride for a UBO to be restricted to extended alignment. Okay. Yeah, so this is stride 16, this is stride 4. But I can't use, but even with this one, it said that it was aligned. The vec3s are going to be extended, but that was in OpenGL, so I don't know. Maybe I just use the 140 and just assume that that's how it is. All right. In that case, I think we might have a bit of a problem here. So These are all going to be vec4 aligned, I guess, which is fine because we're using them by name. And the size, okay, that's also fine. I think that's going to be, actually that might be a problem. Let's try something. So we're going to grab a, whoa, there's way more commented out code down here. Point light with reflect and specular. Oh yeah, I had specular at one point. Okay, I'll have to revisit that. But first, let's see if we can get multiple lights going. So I'm just going to make a uniform buffer. And by just make a uniform buffer, I mean that's not a thing that you just do in Vulkan. So it's going to take me a minute. I will keep the one light position for now. We'll get that working first, and then we'll pass in values after that works. So, okay, uniform buffer for the standard pipeline. Okay. Default pipeline is here. And the other pipeline is here, and I set up uniform buffer on it yesterday, and it was a big mission. So let's see. I'm gonna actually collapse these. So we've got, we need this descriptor set layout here. We need to make this, and then we need to create a pool, and then we need to see, I still don't understand what all of this is for. Like, why do we need to allocate a descriptor set? What does that mean? So I'm not 100% sure about that, but basically we need this code here, and I need to put that in this pipeline, which is quite a lot. And I need to change every occurrence of debug to delete the debug so that I don't create the wrong thing. And I also need to change the flag, the stage to fragment. The size also, where is it? No, actually that's fine. I'll call it the, maybe, yeah, I'll just call it uniform buffer size, that's fine. So it's actually the size of a point light. No, it's not. We're gonna try with this uniform buffer first. So actually, you know what? We could just use. No, I need the uniform buffer. Player position and light position. So 2 vec4s. We'll just do that. Times 2. Great. Now there's a bunch of stuff that we don't have up here. We need essentially these things, but not for debug. Okay, and then we've got another error here, which is what? Layout info is redeclared in this scope. Oh no. Okay, let's see. Damn it, there's just so much code. So that's going to use push constants. And the descriptor set layout, yeah. And this one doesn't have the descriptor set layout, so we want this one. And I will remove this one. Okay. I mean, hopefully that was enough, but I have a feeling something is going to be broken. Let's see here. Okay. Okay, well, the scene renders, but we got some errors here. Right. So basically, we didn't bind the descriptor set. Yeah, okay, that's fine. Bind descriptor set. So we need to do this in the other drawer. What is this called? The default drawer call, pipeline layout, and we want pipe normal descriptor set. And yeah, that should be fine. Okay, that's good. No Vulkan errors, that's good. The lighting is still working, that's also good. Now, if that's the case, can we update this light position over time? Now we're going to need to push to the uniform buffer, which is a bit different to what's it called? It's called upload? No. Right? I've done it before. Where is it? Yeah, we've got to do this. Well, not exactly this. We've got to bind buffer. Yeah, here it is. Okay, so we've got to get a pointer to our buffer, and then we've got to copy our memory, copy our data into it, and then we've got to unmap it. Which I think we can do each frame. I think that should be fine. So let's have a look. I did it somewhere else for the uniform buffer. I want to find that one. I remember it had a vec4 type. It was called data. Here it is. And there's a little fix me here because I didn't want to leave it here forever. Cool. So basically I want this. Yep. Yeah. Interesting. Oh. Right. So with the uniform buffer, you can get a pointer straight to the data, and then you can just update the data. I mean, I did this last night, but I guess I didn't really think about it. You don't have to call another function. You don't have to copy it into an intermediate buffer. You can just write to it directly like this, which is pretty cool, actually. All right. Okay, so we're going to do that before we begin rendering. So we'll do it here, I guess. Before we acquire the next swap chain image, we'll say update light positions, perhaps something like that. So this is going to be not the vertex buffer, but the uniform buffer memory. We're going to say uniform buffer size. We'll map it to this data, and then, oh yeah, that's exactly what we're doing here. But I just had a, yeah. Never mind, I was just being silly. It's just being silly. So we're gonna, there's no point using defer here. I don't know, whatever. I hardly ever use defer. Some people use it a lot. I usually just put stuff in between. It's nice though, because the thing about defer is if you ever have something where you need to call this first and then you need to call this at the end, you can just write them one after the other, and then you know you're never going to forget, which I guess is good. Maybe I should get into the habit of it. Because if you know you've got a pair of calls and you can see right now, okay, I've done this one, then I guess you can just put it out of your mind. So maybe that's a good idea. What we got back here is actually pointer to vec4s again. So I'm going to say that is... What's wrong with that? I need to cast it. Alright. Does that work? No, it's saying cannot assign value of 4 F32s to raw pointer. What? Right. So we're getting a list of vec4s, but we don't know how many. That's what this says. And or a pointer to an array of vec4s, but we don't know how many are in the array, because in Odin, arrays usually have a length, but this type of array doesn't. So I know how many there are, and I'm going to say data1, because that's going to be the light position, equals, let's see, time. How was I doing this before? Let's say, we're going to say it equals 0, 1, and then Noctian says, yeah, and then you combine that defer with an or return or whatever, and you get the exact same control flow pattern you would normally see with gotos in C. He rewrote a lot of his C stuff in Odin, and it's so much nicer to read. Yeah, true. I like or return, it's pretty good. I was going to do a sine wave here, so I guess I will get the current time or something. Time now. No, I think there's a better way to get this. Get current time. That gives us a... Wait, what? That's a bit weird. Using map/unmap, that is a bit more advanced. You can use vk command push constants for simple stuff. If you're just experimenting, I don't recommend push constant for mobile. Some old phones emulate them. I am using push constants for something, for the model and view matrix here. So you can see I'm doing that right here. But this uniform is going to have up to 128 lights, and I don't think that's going to fit in a push constant buffer. So I need to use the map/unmap. I'm pretty sure. At least that's what I understand. I'm still pretty new to Vulkan. What am I doing? Get... Okay, time dot something. I want something. You know what? I'm just going to say start time is up here. Do I have a start time? Time.now. Okay, so time since duration seconds. Then I've got to cast this to a float 32. There's a lot of parentheses going on here. Maybe I'll move this out of here. Time since then I'll just get a sine of time since start. No. What's wrong with this? Oh, right, yeah. And this can be 0. And I'll multiply this by, let's say, 10. So we should just be moving back and forth, right? That's the idea. And well, the lights, yeah, it's moving. That's the wrong way. So the axis I should have used is X, not Z. And let's say 1 and 0 and 0. But there we go. All right. Cool. Now I'm going to attach a debug shape to this. So, how do I do that? Where was I putting the debug shapes in? It was up there, which means I need to use this again. I kind of don't want to call the debug shape. No, I have to. I have to do it every frame. That's fine. Okay, we'll just do that. That's okay. I'll include the fix me. Okay. Whoops. Alright, so that is definitely wrong, and we'll move this here. Good. You know, I stopped using Odin format, but I really want automatic removal of blank lines that have a tab or a space or something. Because I hate when I look at my Git and then it's like, got this here. The .wolf says you can do it with push constants. It has offset and size, but is okay to map/unmap. It should be your final version. It's just that command push constants is simpler. Yeah, that's true. I thought push constants could only be 128 bytes though. Isn't that what it said? I thought that's what I read in here. So if we have a look at, or is this what you're talking about, offsets? Okay, offset 32. I'm sure I read that you could only push 128 bytes somewhere. It's not on this page though, so I'm not sure. Well, anyway, we're almost done with this one, so it's fine. I'm gonna move this out of here, and I'll just put the the spec states minimum 128, but then when I read someone talking about it, it said so you shouldn't use more than 128, I guess, because that's the minimum. So it's like, okay, I understand. So now if we grab one of these guys, and we say, let's make a new one, data3 is going to equal to test light position, but data3 .w is going to equal to debug shape as f32. I'm going to put in a cube. That is, what color cube should we use? This is the tough question, you know. I'm thinking yellow, but we've already got a yellow one. Let's try orange. Yeah, minimum for the from the perspective of the graphics vendor, so you can rely on it always being at least 128. Yeah, that makes sense. Yeah, so that means I wouldn't want to go over that amount, basically, because I wouldn't want to break on like random people's machines and then I have to totally change my code. That would be annoying. Well, that's working. What do you think? Looks pretty cool, huh? I would like to draw spheres, but yeah, this is fine for now. I don't want to go through the hassle of figuring out sphere vertices at the moment. Although I did realize, I think it was kind of, we drew these with, what are they called? Line strips? Not line strips. Triangle strips. These shapes. But actually, there's no need to do that. It's just because the source I got it from, that video, he was using triangle strips, which totally made sense for his problem. But for this, I mean, we could probably just use normal triangle vertices. Triangle list, rather. But anyway, either way, it's fine right now. So cool. All it would be is like, we just change it a bit in the shader, and then we change one value in the drawing loop, so it's no problem. Cool. Alright, I'm pretty happy with that at the moment. We want to get multiple lights in there though, so that's the next thing. So if we go back to the shader, we've got one light position, but what if we had many lights? And you know what? I just realized we could do the same thing that we do with the debug shapes for the lights. Let me see. We got diffuse. Oh no, we can't, because we need diffuse and ambient, which are colors, right? Ambient's usually going to be, well, maybe not. I don't know. No, we can't do that. All right, we'll store the whole struct for now, and I'll figure out something later. So we'll say point light, and we'll just call it lights. And I'll say we got, I don't know, 32 lights available. Seems like a lot. So I gotta know what the size of this is in STD148. I'm gonna assume that it's gonna be vec4, 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 and then this will be 16 byte aligned, so we might as well say 4 vec4s, right? I think that's gonna be the size. Which means when we're making the uniform buffer for the lights, we can assume that it's gonna be, oops. So player position is 1 vec4 and then 32 more times 4. Hello, Vengeance CNS. I'm good. How are you? 1, 2, 3, 4 times 32. So let's say 128 and 129. I'm going to make 31 lights available just to make it a little bit nicer. I think that will fit all of the data that we need. Okay. Now, I'm going to need to pass in these lights, eh? So, it's not going to be data1 equals test light position anymore. It's going to be more like position, diffuse, ambient, and the size, which is between 0 and 2. So if we go to our point light struct, I'm going to change these to vec4s so that it maps to the right amount of memory. It means we're wasting 1 byte, 4 bytes per field, which I don't like, but we can change that later. Okay. So we're going to make a point light here. I'll call it test point light. Very creative name. And position is going to be the position. So that part's going to stay the same. Diffuse. So now we're going to actually pass it in from the outside. We're not going to set it here. I'll grab these values. We'll just copy them for now. So we'll say 0, 0 0.9, 0 0.9. So that's the color. Sort of that cyan color. And 0. And then ambient, we can just set that to 0.1, and that will set all the fields to 0.1. And since the W component doesn't do anything, that should be fine. Size we can say is going to be 2. And I'm going to say data. So we're getting a... This is going to be kind of annoying if I do it like this. So I think maybe the player position should be a push constant, and then we just have a different buffer for the lights. Because otherwise I'm going to have to offset everything by +1 all the time, +1 vec4. That's going to be annoying, so I'm going to make that now. Push constant, uniform, I'll just call it push constants, and we'll put this in here. Do I have any tricks for alignment in structs in your shaders? I use SCD 430 and I tried to do min field align 16. Align 16 in Odin, but couldn't get it to work, so I manually do it now. No, I don't have any tricks yet. I'm sure I will come up with some, but basically, as you just saw, I was just changing my types to match the alignment. So even though these are vec3, they're actually going to be vec4. And so in my Odin, I just made them vec4s. In fact, I should probably just make these vec4s here as well, because that's what it's going to happen when I push them into this uniform. I'm not sure. I'll have to think about it some more. But yeah, you'd think align 16 should work. Right, so we're actually getting back. This one is going to be point lights. Point lights. So actually what we can do is just put this down here. Get rid of the name. Good. And that looks good to me, I think. Now, we haven't set up push constant, so it's going to complain. But actually, since we're not using it right now, I'm just going to comment it out. And we'll do that shortly. And we'll change this to 32. I think that should be good. This can be data 0. And the shader, we need to actually use the lights. Oh, there's no count. We don't know how many lights are actually being drawn. That's kind of annoying. So, okay, we got to do like data 128 equals no, we don't want to do that. It's so annoying. I guess we could say pointer to uint. So we could say pointer is data 128, and we're going to cast this to a U32. And I'm going to say this is 1. Okay, I think that'll work. Hopefully. Yeah. So what I could have actually done is just move this here. Right? But anyway. I'll decide that in a second. Light count. So this will move us, one element past the end of this array, which would be the start of this value. And then we should be able to set that value to 1. Hopefully. Okay, and then we use that light count down here. So I'm going to say for light. No, that's the wrong language. I equals 0, I is less than light count. Okay, we're gonna get the light color, we're gonna put it here. We're gonna say it's nothing at the moment, and then we're gonna add plus equals add the light color of each light. What did I call it? Lights. Okay, that's easy. And we can get rid of this. And I think that should be good. Let's try to compile it. Did that not work? Okay, I'll try to compile it here and see what happened. Okay, we got a problem with the shader. There's an unexpected identifier on line 9. Okay. Struct needs to be declared before the layout, I guess. Okay, we got a bunch of problems with those and successfully compiled. Okay, whoa. You can't subtract a vec4 from a vec3, line 53. Oh, okay. Yeah, because it's all vec4s. It's kind of annoying. Yeah. Okay. There's probably going to be other problems. Let's see. Simple 3. No, it worked. Okay, great. Compilation. Yeah. Okay, I think we're good. All right, our light doesn't work, but the debug shape is moving. That's good. No errors. Let's see, are there any logic errors? I mean, there must be. So, how can I check if this came through? Well, I can use render doc. And we can have a look at the color pass, this one. And I want to look at the fragment shader. There's something wrong apparently. 252 bytes needed, 2048 bytes were provided. Oh, I see. Well, that's no good. Right. Oh, yes, because I didn't add the size to the uniform buffer size. So if we go down to where we calculate this, this needs to be plus size of U32. Okay, I think that will help. I'll launch it in render.doc again anyway, just in case. Yep, there's still a problem, I think. Let's see. Something wrong with the fragment shader? No. No, it looks... Okay, let me see a different format, please. Does that work? Yeah. Okay. Why is that value even filled in? Oh, that's the, what is that? So I've got position, diffuse, and ambient. And then here, position, diffuse, ambient. Okay. And then size is 2. Right. So position, diffuse, ambient, size is 2, which is apparently... has that been turned in? That's weird. What if I turn it into a... I'll change it to a struct. Struct. So it's vec4 Does it work like this? Vec4, Vec4, and then you int. I don't know if that's correct. Failed to parse. Okay, that's nice. Data. Okay. Oh, that's correct. Okay, cool. It looks good. Yeah. Nothing really wrong there. That's all the correct data. And then if we go down to the bottom, there's going to be one more row, and it's got a 0 in it. So this didn't work, right? I think that's what this means. Why did this not work? So we're casting the... I just want to make sure that we're doing this first. Okay. So we're casting the 128th position. We don't have 128 lights. We have 32. Yeah. So that was just riding out of bounds, but nothing was broken, which is interesting. Okay, that's still not working. We do have 32 lights, right? Yeah, 32 lights. Okay, I'm just going to set up the push constants as well, I think, maybe. Or, I just make a type for this, which would give us hopefully a good result here. So, point light uniform. This is probably not the best thing to call it, but that's fine. And we'll just say point light. And we have 32 of those. And then we've got a U32, which is the count. Where is it? This one. So if instead we have a pointer to a point light uniform, then we can say data dot lights 0 equals this. Count equals 1. This gives us some type safety at least, so we're not doing raw pointer stuff, which is a little bit more error prone. Or a lot more error prone, perhaps. Okay, still not correct. But let's see if the data is getting there. Okay, drawing the index. Okay, here's the buffer. Oh, I didn't save the format, damn it. What was it? Vec4, 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 U32. I think it is. Okay, so that looks correct. What is this? Position? Yeah, that's fine. But the... wait. Yeah, so the size is here. The count rather, and it looks like it's a 1. Okay, if I just change it into a bunch of uints, then I'm going to get a 1 down there eventually, right? Near the bottom. There it is. So it is coming through. I'm not sure why. Maybe we'll just check the shader. So the data is correct. It must be the shader, right? I is less than light count. Light color plus equals this. So we did change this, but XYZ, 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 XYZ. Okay, what if I was to just say light color plus equals 0.2, 0.20, just to test that part. Okay. Interesting. Did that actually just make the whole thing, the whole scene more red? Probably would, right? No, it didn't do anything. I'm confused now. Okay, I feel like I'm doing something silly again. Let's go back. Back. Oh, not that far back. Actually, yeah, we'll go that far back. I want these values here. Oh, did I not copy them? There we go. I don't think that's going to change anything, now that I'm thinking about it. Doesn't make sense. Alright. Do we compile? No. Right, so can't convert from a 3 component to 4 component. There's no I, and we used the subscript on something that doesn't exist. Yeah, right, okay. That makes sense. So we want to pass in just light here. Is that all the problems? Why did I compile here? Nope. Cannot convert from 3 component to 4 component, line 108. Right, yeah, okay. Fair enough. Okay, that time it worked. Do we have a light? We have a light. Okay. Interesting. What if I pass in this? Lights 0. Does that work? Yeah. Alright, we have a moving light. So it was working. And the problem was perhaps count. Let's have a look. Is that what it's called? Light count? Yeah, light count. No, it's not F32. Float light count. And then 0, 0, 1. So this should make the whole scene red, but it's black. So light count is not being read correctly on this side. Yeah, alright, interesting. So I suppose my understanding of the size of these vectors is wrong. I don't know how to debug this. So if we look at the pipeline state here, you can see we've got this buffer, and we were looking at it before, and it does have all the things. Vec4, 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 int. Maybe I should add more lights and then see if it still comes through correctly. I mean, that looks correct, but let's see. So I'll add more lights first. Just add like 2 more, and I'll put them in different spots, and we'll use the same values, I guess. We'll say the count is 3. That doesn't really make sense because they're separated in the array, but that's fine. That's not what I wanted. I wanted this application, render doc. Gonna load it up again. All right. So we're drawing. Gonna check the, what am I looking for? Pipeline, fragment shader, buffer, view contents. Gotta write this again. I'm just gonna save this. It's really annoying. Struct data, vec4, view ints, and I'm gonna save as what should I call it? Light, point light, I guess. Okay. Are you sure you wish to override point light? I mean, yeah, fine. Apply. Okay, we've got the same value here, the same value here. So that's all working as expected. So the stride I expected is correct. You know, we've got index 8, index 3. That's all working correctly. It's just this number here, which is at index 32, which is what I would have expected because there's 32 of them. So this value is going to be the number 3 in uint, but when we get it out of here, it doesn't seem to be the number 3. That's what I'm saying. So if we look at here, I've got converting it into a float. I'd expect that to be the number 3. So that would be very bright red, right? What if I say if light count is greater than 0, red is 1, otherwise, no, that's all. And then we'll do float red equals 0. Building too many shaders. Okay, yeah, it worked. Okay. Alright, yeah, but it's still 0 somehow. What is the problem here? I mean, obviously it's... That's the right position, right? Are the members in the light array tightly packed such that the count member is read earlier in memory for the shader? No, backseating is good. Thank you for backseating. I like it because it expands my brain power. Are the members in the light array tightly packed? Like, would it work for 1 point light? Oh, okay, I see what you mean. So if I put something like this, right, and then I change this size to size of... Oh, hang on a second. That's the wrong size, isn't it? Oh no, that's the size that I calculated, but maybe that's wrong. Yeah, I think it is wrong. Okay, I think you're onto something. I'm gonna leave that here. I'm gonna change this to size of point light times 32 plus size of U32. No, don't be sorry. Thank you. I appreciate it. Okay, we still don't see anything, but that's okay. Let's have a look at the data. Fragment shader, buffer. Okay, there's something wrong. We expected this many bytes, but we got 1668. Oh, okay. So I think maybe my calculation before was correct. So the size of point light. Oh, wait, I made a new uniform for it, didn't I? Wonder what the size of that is. I kind of want to know. So I'm going to get rid of this and build. And I'm actually going to run it in the debugger because I want to see. Pause. Okay, and we're here now, and I want to see locals, BK context, uniform buffer, size 1668. Huh. So, okay, I think that's why we've got it. Yeah, you're right. We've got a mismatch of the memory layouts. So basically, Odin is treating this as okay. So Odin is treating this as a 4-byte align struct, I guess. Right? So there's no padding? Let me have a look. Let me have a look at the type in here. Can I see it in here? I can't look at the point light type. Oh yeah, there's no types available. Can I look at the size of? No. Can I look at the size of the point light that we declared down here somewhere? I'm gonna have to move to multiple files at some point. Okay, we'll just get it to here and we'll have a look at the data, which is a pointer to here. So size of data.lights 0. Size of could not be found. Oh yeah, it doesn't have an underscore in here. Size off is not the correct thing to call. 52. 52. So this should be 16, 32, 48, and then because it's SCD 140, this is going to be 64. But the Odin size is smaller. So it's just a coincidence that it looked like it was working, I guess. Okay, cool. That's good. So if we use the, is it align? Like you were saying, align 16. Now what do we get? Let's have a look. So we're gonna run into exactly the problem you were talking about earlier. Now it's 64. That's what we wanted. Okay. If we run this in here, is it gonna work as we expected? Yes. Very red screen is what we expected. And if we have a look at the buffer, if I put this value in here, it's going to be wrong, right? Yeah. So this is actually incorrect. So it should have been uint and then, you know, vec3 or something like that. To pad it out. Yeah, so this is correct. And now if we scroll down to position 32, we got that number in here, which is 3. Yeah. Cool. This looks like it's going to work. There's also a min field align as well. You're not 100% sure how to use them. Well, this seems to work. Let's have a look. So we're going to change our shader back from all of this stuff. We don't need that. I think we'll get rid of this and put this back here. Let's just see with one light and get rid of this. Okay, yeah, one light's working again, good. Can we get multiple lights working? And also I need to move the lights into the correct indices. So I'm going to go down here and we're going to move these into 1 and 2. These all have the same position, so I'm going to offset them by, I don't know, maybe the y-axis or something. Just so that they're not... what's wrong with this? Oh yeah, this needs to be braces, not parentheses. Hello, what is happening? I was pressing W instead of R, that's what was happening. Okay, we should have 3 lights. Oh, I think maybe 1 is too small. But we can only see the lights in relation to other things, right? But yeah, we can see there's a second one up here. Because you can't just see the lights out in the void. There's no fog or anything. That could be something to work on. Okay, so this is working. There's multiple lights. I'll change the color of this one to red or something. 0.9. I don't know why I'm using 0.9s everywhere, but that's fine. This one can be red. This one can be magenta. Red, so no green. Very good. And I think those are too far. So I'm going to say this is going to be up by 2. This is going to be up by 4. And then we're going to change the size of them to 1. So the small lights. And yeah, blue, red, and purple. Yeah, I can see that. That's cool. Yeah. So it was the data layout strikes again. I'm pretty sure I get burned by that every single time. Every single time. I'm sure after a few years of graphics programming, it'll be second nature. But yeah. Cool. Das ist gut. Alright, I'm gonna actually just leave this up for 1 second. I gotta go to the bathroom. I'll be right back. If you guys end up leaving, then thank you for joining, and I'll see you next time. But I'll be back in just a minute. All right. Coffee has been replaced with water, so hopefully I don't get a headache. This is looking pretty cool. Now the other thing I wanted to do if I had time, which I may have time, is to get terrain generation working. Actually, I think I might be overestimating my abilities here. Yeah, well that's kind of the next thing that I want to work on. Because it's cool to have lights in a sponsor, but yeah, it's not really a game. It's not. Well, I do want to do shadows as well. Maybe we should work on shadows first. Let's have a look. I think there's some shadows in here. Let's see. We've got light casters, yes. That's not it. I think it might be an advanced lighting. Shadows. Shadow mapping. Right. So I don't like shadow mapping, but I don't know how to do anything else, or even how to do this. So I figure we should start with this, and then maybe later I'll use something else. And the reason I don't like it is because I think it just ends up looking a little bit meh a lot of the time. Although I guess it depends on the style of your game, right? So if your style is very sort of lo-fi, then I guess the thing that I'm talking about is the what do you call them? The pixelated shadows, I guess you would say. So man, my mouse is breaking. This sucks. I really love this mouse. It's gonna do a little product placement. The old Logitech G502. I think they don't make them like they used to, but yeah, we'll see. The thing I'm talking about with the shadows is this sort of rigid thing that you see with this sort of pixelated look. So you can see it here in this image right here. Actually, this one's even more zoomed in. No, that's the floating one. Oh, jeez. So we zoom in here, we can see these really jagged edges. That's just because of the way that it seems that these shadows work. Now, I don't know if this is a real-time technique or not. So I'm gonna have to look a little bit at this. I think it is. I think it is using the depth map, a real-time technique. There's nothing. Let's have a look. Bake. There's nothing about baking shadows in here, which I guess is good. So shadow baking only really works if you don't have a day-night cycle or something, right? Or I guess it would work on interiors where you can't turn off the lights, or anywhere where there's constant lights. You could bake the shadows, but anywhere else where anything is dynamic, you can't really do that. And since the whole game is going to be dynamic, I'm not even going to look into baking at all, I think. I'm just going to avoid that topic. Or maybe I'll look into it, you know, at a cursory glance. So this is something called PCF, percentage closer filtering. So this is making it a little bit less jagged around the edges, which is better. Okay, I guess we can try and implement this. There's just a lot of text here. Let's see. If you're running unblock, please consider whitelisting. Okay, I'll do that. Wow. Maybe that was a mistake. There's so many ads. Okay, so it's a good resource though, so I want to give them my click money. Give them my views. So, shadows are a bit tricky to implement. How long does it take to get a flat belly with chair workout? Well, it depends. How many calories are you eating? That's really the question. It's got nothing to do with this. It's so funny. I always thought those ads were a bit weird. On when I was little, on late night TV and stuff, they'd have the super awesome machines that would burn fat in 6 weeks or whatever. And it's like, okay, but if you're still eating the same amount of food, maybe you're going to see a marginal difference. Maybe you'll build some muscle under your fat. Oh, the electric belt thing? Yeah. Yeah, I remember that. It's like, yeah, the electricity stimulates your muscles. It sounds good, right? It sounds great. I actually quite like working out, though. It was really hard to get into, but after doing it consistently for like 3 months, then it became more painful to skip the workout, if that makes sense, which is weird, because I guess it releases a lot of nice chemicals in your brain and stuff. So the idea behind shadow mapping is quite simple. We render the scene from the light's point of view, and everything was... Oh, that's easy. I mean, I say that's easy. That's an easy concept to understand. Alright. So anything we can't see must be in shadow. Yeah, that makes sense. Right, so we're going to get a depth map from the light's point of view. Is that how this works? If we were to draw a line or ray from the light source to the fragment, on the rightmost box, we can see the ray hits the floating container before it hits the rightmost container. Yes. Yeah. So the floating container's fragment is lit, and the rightmost container's fragment is not lit, and thus in shadow. Yes. Okay. We want to get the point on the ray where the first hit an object, where it first hit an object. So we're going to use ray marching? I wonder how they do that. And compare this closest point to other points on this ray. Then we do a basic test to see if a test point's ray position is further down than the closest point, and if so, the test point must be in shadow. Iterating through possibly thousands of light rays from such a source is an extremely inefficient approach and doesn't lend itself for real-time rendering. Yeah, apparently. I'm going to look into ray tracing and ray casting, ray tracing and path tracing eventually, and see if I can get a limited, sort of limited ray tracing setup for global illumination. That would be pretty cool. But since I'm using arbitrary geometry, it might be really expensive. Whereas if I was using square voxels, then there's certain guarantees you can make about the math, right? I'm not sure how it would work, but yeah. So you may remember from depth testing, which I didn't read, that a value in the depth buffer corresponds between 0 and 1, yes. What if we were to render the scene from the light's perspective, store the resulting depth values in a texture? This way we can sample the closest depth values as seen from the light's perspective. After all, the depth values show the first fragment visible. Okay, that's pretty simple. Right. Okay. The left image shows a directional light source of all casting a shadow. We may find the closest point and use that to determine whether fragments are in shadow. We create a depth map by rendering a scene using a view projection matrix specific to that light source. This projection and view matrix together form a translation that transforms any 3D positions to the light's visible coordinate space. Okay. A directional light doesn't have a position as it's modeled to be infinitely far away. However, for the sake of shadow mapping, we need to render the scene from the light's perspective, and thus render the scene from a position somewhere along the lines of the light direction. That makes sense. In the right image, we see the same directional light and the viewer. We're under a fragment shader point, so this pixel here. for which you have to determine whether it is in shadow. To do this, we transform the point to the light's coordinate space using the transformation matrix. Okay. And since point P is now seen from the light's perspective, its Z coordinate corresponds to its depth, which in this example is 0.9. And, oh, okay, I see. So we can now also index the depth / shadow map to obtain the closest visible depth from the light's perspective, which is point C. Since indexing the depth map returns a depth smaller than the depth point at P, so from our point of view, it's 0.9 depth. From the light's point of view, it's 0.4. Therefore, it's closer to the light than us, so something's blocking it, right? Okay. First we render the depth map, and in second pass we render the scene as normal, and use generated depth map to calculate whether fragments are in shadow. Alright. Here we go. It's all OpenGL, so I'm going to have to translate it, but that's okay. So the depth map is the depth texture as rendered from light's perspective. Okay, so we'll need another depth texture. That's fine. We can do that. And then generating the depth map shouldn't look too complicated. Okay, we only need the depth information when rendering the scene from the light's perspective, so there's no need for a color buffer. A frame buffer object, however, is not complete without a color buffer. So, okay, yeah, this is some OpenGL stuff. Okay, so let's see if we can get the depth buffer from the directional light's point of view first, I suppose. Actually, I need a little bit of more information, which is this part here. The light space transform. So we're going to look at the light source's position, looking at the scene center. Okay, all right. So we'll make a depth buffer first. So I've already got a depth buffer here, which is part of. Actually, yeah, I wanted to check if this was a mistake. Just real quick, if I just change this type. Program is open, cannot compile. Okay, I think that was a mistake, since everything is working as expected. Okay, good. Actually, before I start this, I'm gonna commit. Let's have a look. What have we got? Quite a few changes here. So we've added multiple lights. So we've added a new uniform buffer to the main renderer. Added UBO to default pipeline for lights. And that's about it, actually. I didn't need to open Vim. Okay. So you say your parents got one of those electric belts. Did it work for them? Did they ever use it? Did they put it in the closet and then just forget about it? No, it didn't work. I think they used it for a week. Yeah, it's one of those things, huh? It's like an impulse buy. And then you just put it in the closet. I got so much stuff like that. Like a soldering iron kit, Arduino stuff, some like sensors and things. I was like, yeah, I'm gonna do electronics. And then I just didn't do it. Right. Yeah, okay, let's make the depth buffer. So we need to get another depth attachment. so this is going to be the shadow depth buffer. Actually, I'm just going to copy this. It's basically the same stuff that we need, and then I've got to go down here. So we got create the depth buffer. Yeah, I think it's exactly the same. So I'm just going to copy this block. They did invest in a rowing machine. That one has seen almost daily use for years. Yeah, rowing machines seem pretty good, hey? You want to get one yourself? Nice. So here's the shadow depth buffer. Ooh. So it's actually all exactly the same. So that's just creating the texture. But we do need to put it somewhere. So on the pipeline, oh, you can just do it dynamically. Depth attachment info. So does that mean there's only one depth attachment? Damn. If there's only one depth attachment per pipeline, does that mean we need a new pipeline for drawing to the depth buffer? Or do we just need to do a different render pass, maybe? So yeah, I think we need to do a second render pass. So we begin rendering here. Using this rendering info, and then we probably want to, before we do this one, we want to do the other one, right? So we're not rendering to the swap chain. Can we use the same command buffer? I don't know. So far it's been easy because we've just been drawing everything to the same swap chain image, which has been great. It's actually very simple. But now we want to draw to a specific texture, which makes me think that I probably want to set up something else. Let's see, begin rendering using this rendering info. This rendering info has the depth attachment. The depth attachment has the depth buffer image view. Therefore, I can't use it. Maybe I can change it actually. Let's say pk.cmd depth. What is in here? There's a lot of things. That's nope. Okay. I think there was something for descriptor sets. No, that's not what we want. Attachment maybe. Clear attachments. Set rendering attachment locations. Okay. This is interesting. Maybe I'll just check this site here. Set rendering attachment. Oh, why is there no results for this? Oh, because this is ticked maybe? Oh, God. Is that not what it was called? Set rendering attachment locations. Rendering attachment location info. What is that? It's got color attachment, Damn. So that's not what we want. Rendering attachment info. Okay. Obviously I don't know enough about Vulkan to do this within the time allotted. I'm thinking that what I want to do is do it up here. So draw depth, shadow depth buffer or something. Generate something up here, and then it would be I don't need to get the swap chain image because I'm not drawing to the swap chain, I'm drawing to a texture, right? So I think I could do something like this. Don't need a clear color. There's no color attachment, right? Or do I need a color attachment as well? I need to get a command buffer from somewhere. So we've got this per frame command buffer, which maybe I could use that. I'll see. Since I'm going to stop using it straight away after, but then I've got no fence. So there might be an issue. Oh, I'll find out. No color attachment. Only a depth attachment. And I'm going to begin the pipeline, and then we're going to... I guess I have to set up all this stuff. It's kind of annoying. I got to figure out my abstraction soon, because the amount of code duplication is getting crazy. But I don't want to do it too early, because it really bit me last time when I did it too early. So if I go to the next end rendering, yeah, okay. And then I guess we got to end the command buffer here. Which, did we even start it? No, I didn't start it, I'm pretty sure. So that would be after acquiring it, I must start the command buffer. Can I just make a different command buffer? Right, so this is just, where is this? I've allocated command buffers here. Created a command pool and a fence. Right, okay. Begin info. Command buffer submit. I remember reading about this, one time submit. Can't remember why I was reading about it, but it was something that they were very happy with. I think it was because you could use command buffers without a render pass. I think that was the idea. Okay, I'm pretty sure this is going to break my program, but that's okay. See, I don't want to draw to... Where are we drawing to? The current depth buffer imagery. So yeah, we want to draw to the... What was it called? Light? No, shadow. Shadow depth buffer. We'll use the same graphics pipeline. I think that should be fine. Not 100% sure. We'll just keep everything here the same. And then I guess I'll just try to compile this and have a look and see what happens, eh? Compiled successfully, but will it run? Okay, it's not very happy. Let's have a look. I had a feeling that was the case. I'm reusing the same command buffer, so I was not happy about that. If the command buffer was allocated from the command pool, which did not have the command pool flag set, command buffer must be in the initial state. Okay, what about this part here? Currently bound pipeline has a color attachment, but I'm not using one. Yeah, okay, fair. I can see how that might be a problem. So I needed I need a different pipeline just for doing depth attachments, I guess. Okay. Or I could render to an image anyway. No, I don't think that's a good idea. Maybe just to get it working though. I mean, maybe just to see if I can get it working. So if I put this p color attachments equals color attachment count is 1. I'm just going to render to the 0th view here, and that's going to be a big problem, I think. I think that's going to make big issues. Color attachment is not... What's the problem? Did I misspell it? Oh, I misspelled it originally. Color attachment. Interesting. Okay. Well, it's working. It's not happy though. What's the problem now? So, it's basically I didn't reset the command buffer or something like that. Let's see if I can do that. Is there a reset command buffer? Yeah, there is. Command buffer. Is that gonna be okay? No, it doesn't really like that. It could be something about the pool. So it's created from a pool that doesn't have, that has the transient bit, which means we're not reusing them, I guess. It's been allocated from a pool with reset command buffer bit. Okay, so that's not allowed, I guess. Alright. So there's a couple ways I can think about this. If we change the pool, oh, this resets the entire pool, huh? Okay, what if I do that? But I'm not waiting for the fences. Maybe I should. Maybe I should just acquire the swap chain image. And that'll give me... Hopefully, where is it? Acquire, swap chain, image? No? Swap chain image. Where is it? Here it is. Okay, so what if I do this here, and then I do it again here? That's fine. Okay, and then instead of using index 0, where did I use that? It was somewhere here. Did I delete that? I'm not going to reset the command buffer anymore because that happens. I think that's all. No, it's here. Well, I don't think you're supposed to do this. No, you're definitely not supposed to do it, because my game is frozen. It's just waiting for the next swap chain image forever. Okay. Already previously acquired 2 images, only 2 are available. Yeah, okay. So that didn't work. Alright, it shouldn't be that hard. Okay, let's see. There's just some missing pieces that I don't have, that's all. So I think maybe the best idea is to make another what do you call them? I'll make another command buffer pool, I think, for this, or maybe just for like random stuff that I want to do, and then I'll make another pipeline because we don't need the color attachment. I think that's probably what I'm going to do, but I'm going to do that probably offline. It's not really that interesting to watch anyway. And I have to go anyway because I got to do work. But I want to thank you guys for joining me today. It's been good. We got the lighting working again, which is very nice. Just going to stash this and build and have a look at it again. So yeah, we got up to this stage, which is much better than we were at when we started, so that's cool. Alright. Thanks guys, and I will see you next time.